Okay, we can start again. Please, I would love if you open the link that I attached on the Word file in the shared folder, so you can access this Word file here. You can just copy and paste into your browser this one. I'll give you just 1 minute so everyone does it. Okay, did everyone open this? If someone is struggling, please raise your hand so we can troubleshoot it. Okay, great. So if everyone is with me here, what these are, as I told you before, the results of our first GMPS2 job. So the status is done. Here we can see some like general features of the job, like the time it took to be to finish, which is this one at this step, and what we can do in here if maybe if for example we want to repeat this job but we want to change the input files, we can just click clone job. We want to repeat the same workflow but with different files. So instead of like going in workflows looking for feature base and whatever, we can just click here. Please do it. So we look what happens. And what pops up is the job we just submitted. So the complete job we just submitted. And we can, just by clicking this, remove the file that we input before and just upload different files as you already saw before. So this is what I want to show you now. This is the only thing you have to do. You don't have to struggle to look for the workflow and so on. So, but let's go back and let's analyze the results of our job. Let's go back to the first page. And if we scroll, what we see here, we see many results, links, and many white squares, white buttons. And all of those are results, basically, from our molecular networking job. The first things that we maybe want to know is, did we have some library hits? Do we have some molecules which are matching some library hits? So the first thing I usually do is to click on this one, because maybe I'm looking for some specific metabolites and I wanna check if they are there, if they have been detected. So please, all of you, you can click on library results. And this one should pop up. Does everyone has this? Okay, great. Okay, what we can see here is like mirror, the view of the mirror, and now in a second we are going to explore it. We have the scan, which is basically of course the scan of the molecule, but it's also a specific identifier of that kind of feature Then we have the compound name that was measured through the library, and okay, we have the ion, the kind of ionization, the precursor mass of our molecule, the cosine score. So 0.99 is pretty high. So we are going to expect this feature to see if this cosine score means that we have a perfect match. And these are the shared peaks between our metabolites and the library hits. The mass difference, of course, is 0 in this case. And then we have this spectrum ID that you will learn more about it from Daniel. But what we can see is like, maybe I'm curious about, I don't know, this metabolite, and I want to see if, which is like the pairing of the peaks between my metabolites and the library. So I can basically click on view mirror, and what should pop up is something like this, where we have our spectrum on a side, the library spectrum on the other side. We have like, we can basically tune the parameters in order to zoom in, to zoom out. We can do many things. And we can also rotate the labels, like in this case, maybe we want to have them fitting in this way, because this is something that then we can export directly for our publication or for our papers or our report. So we want to have like a pretty figure, so we can decide many parameters you can play with in these days for sure. But another important thing that we see here is the USI, Universal Spectrum Identifier. This is really important because through this, when you have like the USI of your molecule, you can do many searches in the different tools. You can use it, and it will be required if you keep following and keep using GNPS in many other workflows. So when we speak about USI, is this code that you can access in this way. And let me see other important things. Yeah, basically here you have a list of the peaks, but this is not something really useful. And yep, you have the USI of our spectrum, and you have USI also of the library match. In this case, they are basically the same molecule, but you can access both. Now, I will go back to the previous window to inspect other things that we can see here. Okay. You can basically scroll and you can see how many hits did we have. And we had like 255 entries, 255 hits. But of course, I would, as I showed you, I would always, like, if a feature is really important for you, I would always go into it and to check the mirror match. Are you okay with that? Is everything clear about the mirror matching? Great. So we can go back to the main page. And another cool thing of GNPS2 is this. Basically, if you click, sorry, I did it, but I didn't tell it. If you click on cluster summary here, you can basically see all the molecules, because here in the library results, we only see the molecules that got hit in our library matching. But if we want to inspect all the features, how do we do that? We can do it here in cluster summary. Let's click on it. And this is really important when you want to do a quality check of your molecular networking job, and you want to see if you scroll, this number should be the number of rows of your quantification table. So the two numbers have to match. In this case, they match because I checked it, but it's just because this is the number of features that you have in your molecular network, and we will visualize it later. So what we can see here is, like, as before, like you can view the spectrum, you can view the box plot, and I will show you how. This is the cluster which identifies these metabolites. You have the parent mass, so like a lot of features that we need to say that, okay, this is that metabolite. And of course, for this one, we don't have any identification. But for example, if we go here, it was really interesting in this one, in Irgarol, and basically, this is an anti-fouling agent used like for on sheep and whatever, and in order to repress the growth of like algae and other organisms. If you can this way, by clicking here, you can use spectrum. As we saw before, here we don't have any mirror matching. In this case, we can only see the spectrum of our metabolites, and we can play around as before in the same way. You have the USI, so all this stuff is stuff that you might need later on. But coming back to the previous window, what we can check, and it's really interesting, is the box plot. In this case, if you click on box plot, you will have this kind of window. And what you can do here, you can play, if you uploaded some metadata, you can play with metadata to see, but how is distributed these metabolites around different locations of different time points of whatever. So what you can do here is, if you scroll, you can play with the attributes that we assigned in the metadata. This is something that you assign only if you have the metadata. And we can, for example, click on simple area, and we can see how these metabolites is spread around different areas. And in this case, it's a pretty interesting thing because this metabolite is only present in this location. So this is something you can quickly do. Is a quick way to inspect. It's not this doesn't substitute the statistics pipeline, but of course it's something that you can quickly check in your data if you uploaded your metadata. As before, here you can do many things, but mostly you can export in different formats your picture, and so this is like pretty ready for a paper or for whatever you wanna use it. Yes, some question? Yeah, honestly, yeah, it's just yeah.
An output of all the analysis. If you have GPS on your metadata,
yeah,
then you can directly notice on this. How driving work a lot. We don't have GPS corporates in there.
We have latitude.
Okay. Yeah, can I try and select it?
I think we only have.
No, it might be that we can take a look at it.
Yeah.
But I think it's made for example.
So is everyone fine with that? Great. If you have questions, just stop me. And so we can go back and do to the previous page. Let me see. Okay, we can go to the main page, which is this one. Please, everyone, try to get in this page. Now, one of the most important things that I would do is to visualize our network for the first time after all this job, after all this work, acquiring data and analyzing data through MZMind. I think this is time to visualize our network and to see what are we producing, what are we doing. And so what we can basically visualize in two ways. We can visualize the network, or we can visualize the network and also the nodes that are not clustered with each other. Just for having a simple thing, I will just visualize the network, but you can visualize also the not clustered data, which is the other button. So you click on this. Please, everyone can do it. It takes a bit to upload it. Is everyone on this window? Yeah, I mean, are you uploading your network? Great. In a minute should pop up our network. Does someone has a faster PC? It takes a bit. That's a good test, huh? Okay, I have it. Great. Okay. This is basically our molecular network. We can zoom in, trying to understand which is the structure of this guy. And we can see many nodes. As we learned, every node is a molecule, represents a molecule, a fragmentation spectra, and they are connected based on similarity. This is something that I think we learned during these days. But what are those numbers? And what are those blue nodes? This also I think is a good question. And what we can do, we can tune the labeling in trying to understand it to get more information about this cluster. What we can do is to show in here in node labels, we can click here and, like, for example, show the library match. Issued. Yes. In this case, we have fucoxanthin, for example, here. And but also we can also, I don't know, show the MZ value, like in this case. We can, just by labeling the node, we can do many things. We can, I don't know, also show the retention time or whatever. By scrolling, we can do the smiles. This is not something I would do it. It's like pretty big and it's not that useful, but I mean, you can play around with it and like trying to show whatever you prefer. And another interesting thing you can do, let me just go on the MZ. Yes, sir. Another thing you can do is, as we said, we have the metadata here. I don't know if you realize, but we have the area where the sample were collected as metadata in this case. Of course, we can also change it and use another attribute like replicate or the longitude or the latitude. We can use different kind of metadata. In this case, let's try to work with that. In this case, here we have like show pie charts. There is, it's a no. I would say yes, because I want to see if I can. Yes, like in this case, if I go on library match, I want to see in which location fucoxanthin was more present, for example, if it's a metabolite on which I'm interested in. So I can, like, from the pie chart and from the tab, from the color chart, I can understand where the metabolite very quickly, like the visualization of the results. I can understand where this metabolite was more present among all the locations. I can also do the same with the edges, because as we learned, the edges also tell us something. So what we can, like, for example, between fucoxanthin and deoxanthin, in the middle, this is another important feature. If you click on the spectrum on the node, basically you get the spectrum and the structure of the molecule here of fucoxanthin, and you have all the important information about this node in our network. So you can really immediately see everything about this node. And any question about that? Everyone understand anything? Yes? Yeah. No. Whenever you click out of the box, maybe it's like, yeah, it's just slow maybe. Yeah, that's the thing. Yeah. Who can tell me what an edge tells us about two molecules? For example, this edge, this one. What is telling us about these molecules? That's correct. And something more? Like if you click on the edge, you see the two spectrum popped up. So this is like something important, because in this case, it's a pretty complex fragmentation spectrum. But what we can see that they are probably analogs of each other. This is like an information that we have in this case. And since our both of them, we have ID, we can see which is the delta mass between them. And we can also show it in the network. So very easily, we go here and we go on the edge labels. We don't go anymore on the node labels, but we want to label the edge to try to understand which is the mass difference. And when we go on edge label, by selecting delta mass, and hopefully going here, you see, we are gonna get the mass difference between the two. Now, you see the mass difference is 78. We should like calculate the molecular formula of this difference and try to understand which is the thing which is the part that is of the molecule which is changing. But for example, in this case, between fucoxantine and this one, we have 18.01, which is pretty much water, a water molecule. So I would be pretty confident that this is a water molecule, and also in this case. So the edges can tell us which is the part of the molecule which is changing between two nodes. In this case, we know fucoxantine, but we don't know this one. So we can clearly understand which is the part which is changing in the molecule. So these are all the information that can give you this kind of visualization. Another thing that we can make the edge by clicking here thicker if the cosine score is higher. Like in this case, it's a very high cosine score. While when you have like a low cosine score, you have like thinner edges, like more or less, like in this case, these one are like thinner and these one are like thicker. So this is something for a fast visualization of our network is something very important. Like playing with colors, playing with thickness of edges, with size of nodes. This is something that can really help you to understand your data very quick. Okay? Do you have some question on request or? Okay. I think here you can play a lot. You can do many things. I think the best way to learn it is like to play with that. And I hope you will do it in the next days. Here you can also change the ratio, so you can have like more space for your molecular network and to see more things. And yeah, you can zoom out. I mean, this is what stuff that you can do. But of course, for a complete visualization of our network, the best thing would be to have it on our PC. So we don't want to do it because if maybe we don't have any internet line or whatever, or we just want to do it things faster. So what we can do is to download this network and to open it in another program, which is Cytoscape.